during which we will discuss. I will want to cover the impact which analytics has had on the BPO industry. So that is pretty much what we'll cover during the course of the session. I will try and split it up into a number of sections, starting off with the aspects of the BPO industry which analytics has had an impact on, following it up with actually a live data set of what the BPO industry data actually looks like based upon my personal experience. And finally, probably the last half an hour of the session devoted to how to actually approach and analyzing a BPO analytics data set to try and solve a business problem. So that's pretty much the agenda that we'll follow during the course of the session. I guess some of you might have attended some of my past sessions. So as with past sessions as well, and I just want to reiterate that in case you have any questions, please feel free to ask, but I would definitely feel more comfortable if you voice out the question. So I'll be on, I won't be on mute throughout the session, so that anybody who wants to shout out can always ask whatever they have on their minds. I will try and keep my eye on the chat window, but very often that might sort of surpass my attention. So in that event, it's always better if you sort of voice out whatever you want to ask. Okay, great. So let's get started. I just want to ask once again before I begin, am I completely audible? Could someone just voice that out?
Yes, you are. Yes.
Yes, you are.
Yes. Yes.
Okay, so there is somebody in the chat window saying this is not audible. I'm not really sure what that means. I can assure you this is me, as far as I'm aware anyway. So there's some people saying voice is not clear. Well, I'm pretty much as near the microphone as possible. So anyway, so since I'm audible to the majority of the people, let me just get started with what I want to discuss. I think it's already pretty late. So when it comes to the BPO industry in general, right? So there are a variety of factors which the BPO industry considers. So I think whenever we think of BPO, we primarily think of call centers, right? So in terms of how call centers cater to a variety of clients in terms of their voice needs, and sometimes even their non-voice needs I'll reach out to customers. It could be to solve customer problems. It could be to make sales to end customers, and for a variety of other reasons. So having said that, why don't we just dive right into some BPO problems? So I hope you can see my screen. What are the major BPO objectives that we are facing nowadays? So based upon my personal experience and actually sitting with call center teams and understanding their issues on a day-to-day basis, what I sort of understood is the primary problem which they go through is attrition. So for those who actually are not aware of what that term means, essentially what it means is tremendous loss of people and churn of employees on a day-to-day basis. So the attrition, in fact, at these call centers is so significant at various points in time that the attrition almost tantamounts to around 70 to 80% per year. So much so that it amounts to 11 to 12% amounts of attrition every month. So that's quite significant. It hurts the operations significantly in terms of having to train employees to cater to company calls and a variety of other factors. The second important factor and target which the BPO industry looks at is metric improvement. So what essentially is metric improvement? So when it comes to, let's say, telecommunication clients, so when, for instance, you are calling up a call center and you're asking for a problem to be addressed when it comes to your bill, or a problem relating to internet connectivity, or a problem relating to broadband problems. So there is obviously a call center agent who answers the call. And many telecommunications clients, be it major vendors like Airtel or Reliance or Vodafone or whoever they may be, they pride themselves in solving the problem in one go. That is, resolving the problem in one particular call, rather than having the customer call back, which is often what we have to do, as I'm pretty certain all of you must have experienced at this point as regards solving a particular issue, right? So that's another objective of the BPO industry, which is metric improvement in terms of how they're able to resolve problems. But having said these two aside, given the time constraints, we'll be focusing in primarily on the third issue, which I hope you can see on my screen. So let me take you back to few years ago when Reliance Jio was launched. So when Reliance Jio was launched, the people who were mainly hit were the competitive providers like Vodafone and Airtel, right? Because they faced a significant amount of churn in terms of the customers who gave up their connections in order to opt for Reliance Jio. So at that point in time, vendors like Airtel chose to set up their own Airtel retention desk. The objective of the desk was primarily to try and urge customers who were churning to actually stay back and try and keep them back as Airtel customers, be it through offering discounts, through cross-selling, a variety of other factors. Okay, so this Airtel retention desk, which exists even now, proceeds to outcall customers who have churned, who have opted out, and to try and retain them. So what we did when I was part of the Hinduja group was to try and help them out. How did we help them out? We helped them out by trying to develop an algorithm whereby we could prioritize customers. We could prioritize customers in terms of who would be the more likely customer to retain, and they should be given priority in terms of activity for retention. So that's the algorithm we will explore today. And that's what will probably take me to the next few slides and then the data set. But at this point in time, since I've pretty much zeroed in on what the problem statement is, does anyone have any questions?
No, sir.
Anyone else? Any questions?
No, it's clear.
Okay, so the problem statement is clear to everyone, right? As to what the objective is?
Yes. Yes.
Excellent. Great. Anyway, feel free to voice out at any point in time in case you have any questions as regards the problem statement. It is not really, it's very straightforward, but the idea basically is to try and prevent churn, trying to prevent customers from quitting Airtel, or in case they have quit Airtel, to come back and join Airtel again. That's pretty much the objective of whatever we will discuss today, right? So having said that, we'll move on to the next term. So what is the role of analytics in customer churn, right? One is improved prioritization, like I said. So what is improved prioritization? So think about this. If I, let's say, have 50 customers, right, who have churned and who have left Airtel. So all of them, based upon their attributes, will have a certain chance of being retained. So for instance, think of a person who has moved from Calcutta, living in Calcutta, and now lives in Andaman and Nicobar Islands. So now, because he's moved from Calcutta to Andaman and Nicobar Islands, the chances of him being retained as a customer for Airtel is very slim, right? Because the chances of there being connectivity there are very slim as well. So he will have a low probability of retention. Now, what if I focus on... Hello?
Hello?
Am I audible?
Yeah, sir. Can you hear me?
Yeah. Tell me, you have a question?
Yeah, my question is, sir, can you explain what is churn?
Okay. So churn essentially means losing out on customers. So for instance, if I had a particular customer who had an Airtel broadband connection with me, that customer suddenly decides, hey, you know what, Airtel's broadband connectivity is horrible. I hate it. They don't give me significant bandwidth, and I am quitting. I don't want Airtel anymore. I'm shifting to something else. I'm shifting to some other broadband connectivity provider. So the moment that customer is lost to Airtel, that is basically what we refer to as churn in business analytics. So a lot of work has been done around churn analytics in the past from a variety of other industries, not just BPO. But for the purposes of BPO, it basically refers to the losing of customers. When a particular company loses customers to its competitors, that is called churn.
Yeah,
does that answer your question? Yeah. Okay. Any other questions?
Oh.
Okay. So,
Sir, no audio.
Can you hear me now?
Yes, we can now.
There is some problem with the,
Yeah, we can hear now, sir.
yeah, there is some problem with the GoToMeeting link actually. It's muting on its own for some reason. But anyway, whenever it's muting on its own, I'll try and unmute. I guess that's why my voice is breaking for you guys.
It's fine now.
Yeah, but it's fine because it's unmuted. But somehow it's sort of going into mute mode once in a while. Anyway, so I gave you the Andaman Nicobar Islands example. So he'll have a very low probability of retention. So retention is what? Retention is essentially the opposite of churn. When I'm losing a customer, then I'm trying to retain him. I'm essentially trying to win him back. I'm trying to lure him with offers, be it discounts, as I said, be it through cross-selling items, be it through other broadband availabilities. And I'm saying that you please come back. I'll give you a better offer. You become an Airtel customer again. So there will also be customers
Hello.
who are easier to retain.
Hello.
Yeah, there will also be
I'm.
customers who are easier to
Am I
retain.
audible?
Yeah, tell me.
Yeah. So I have one question. Sorry to interrupt you again. So
Yeah.
like you have mentioned like churn analysis. So could you please describe like when we use the churn analysis? Are the different scenarios when we use the churn analysis?
So,
If we
as
are
I
low,
said, churn analysis will be done in a variety of industries because it's basically the losing out of customers. So as soon as you lose out customers for a variety of reasons, be it pricing, be it poor service, be it lack of discounts, you basically undergo churn. But in case of BPO analytics, we will focus on churn only in terms of why customers are going out because of a broadband issue or because of a connectivity issue, because of bill dissatisfaction, because of a better scheme being available elsewhere. So that is pretty much what churn analytics is. Okay. So in terms of efficiency gain, what I basically mean was the use of logistic regression or random forest or a variety of machine learning methods. Those two are just examples of how it allows greater efficiency in terms of cost savings, right? So when I say cost savings, I essentially mean that if I lose customers, I'm essentially losing out on revenue. So I'm basically losing people who would have bought me more money. So to get more customers means more outcalling, calling up new customers, trying to get them to join Airtel, which is significantly more difficult as compared to, for instance, winning back an existing customer who has gone. So analytics plays a very major role here in this regard, in terms of winning back customers, in terms of prioritization, as well as through efficiency gain through a variety of methods.
Yeah, hello. Am I audible?
Yeah, it's very muffled. What's your question?
Yeah, so my question is how much more is the cost of acquisition in telecom industry with respect
Your
to
voice is
the
breaking.
cost
I
of
can't hear what
retention?
you're saying. Your voice is breaking. I can't hear what you're saying.
Hello, is it
Yeah.
better now?
Yeah, please
Yeah,
tell
so
me.
my question is what is the cost, like how bigger or how significant is the amount of the cost of acquisition with respect to the cost of retention of a customer in telecom industry?
So, in the telecom industry, a churn of customers is an extremely common thing. It's not something uncommon. It spiked up, especially as I said during the Reliance Jio advent. But analytics has really helped in terms of analytics has really helped out in terms of trying to reduce the churn, in terms of trying to understand as to which customers are likely to churn. So that is where a customer profiling, feature engineering, and a variety of other aspects have come in. So the idea here is not to eliminate churn. The idea here is more to try and reduce churn as much as possible over time to enable telecommunications providers to understand as to who to target in terms of customer retention. It makes much more
No,
sense to try. Yeah.
no, I get this. I get that, but I want to ask, like, whether analytics is important or whether analytics is needed here. Because if the cost of acquisition is lesser than the cost of retention, maybe then you just acquire a new customer than trying to retain him. So my question is whether the cost of acquisition is very much greater than the cost of retention of a customer
What do you think
in
it will be?
telecom field.
Why don't you answer that question since you raised it? Well, what do you think will be more? Do you think the cost of acquisition will be more or cost of retention will be more?
See, I don't have a much of idea in telecom industry, but in retail, it takes a
it
lot
is.
of
Sorry to
cost
interrupt.
for acquisition.
Yeah, sorry to interrupt, but then obviously the cost of getting a new customer would always be higher than trying to retain a customer because you already have the like data points like their contact details and everything, so you can always ask them, give them a better offer or something. So yeah, retaining would be cheaper.
Yeah,
Well,
so I get it. Yeah, but
okay,
you have a cost of
I think we're not hard pressed for
data
time.
science
Excuse me.
team
Hello,
working on
excuse me.
creating a model.
Can you hear
Yep.
me? Can you hear me?
Yeah, I can. Yeah, yeah.
Yeah,
Yes,
yeah. So I think your question has been answered. So essentially, the cost of acquisition in industry you look at will always be more than the cost of retention. Because when it comes to retention, you're basically trying to retain a customer whose vital statistics you already know about. So you know his spending patterns, you know what he's looking for, you know whether he's looking for broadband connectivity, you know whether he's looking for cross-selling with other products, you know whether he's looking for a postpaid or a prepaid connection, and because of that, retaining a customer will always be simpler than the cost of acquisition, regardless of which industry you look at. So that is actually a very simple question to answer, right? So having said that, how do we classify go about actually an analytics exercise when it comes to understanding as to who should be retained and who shouldn't be retained. So the objective of this exercise is basically to try and see how machine learning can actually help out in identifying what are the key variables, and these are the various steps which we go about in doing so. We decide first of all whether what type of machine learning model to use. I have just mentioned a couple in this slide, be it logistic regression or a random forest, but in reality there are a whole host of models you can consider. There are SVMs, there are neural networks, there are probit models, tobit models, a variety of other models which are there. I basically consider two very simple ones and two very popular ones as well, given regular analytics parlance nowadays. So how do we go about such an exercise? We go about through the proper sanitizing of independent variables. That is, we basically try to look at what are the key variables affecting churn, affecting retention of customers. We also look at the division of the data to allow validation of the model. Now, what does this mean? Essentially, once we develop a particular model, we do so on the basis of a part of the data set. And once the model has learned or understood from the data set, and that's why we call it machine learning, because the model has learned and understood from a data set, we try and deploy it on data which the model has not seen, right? And we see how the model does. So this is basically the second point which you see over here, the division of the data to allow validation of the model. And we will do all this as part of the data a bit later on. So it will become all clear. Model formation and quality checks. How do we actually form the model? Model refinement and accuracy improvement. We will see this as well when we try and actually see what sort of accuracy numbers the model is giving. Proper packaging of the model for the end client. Because remember, at the end of the day, all these hi-fi models are pretty nice and neat and high profile in terms of jargon. But at the end of the day, the client needs to understand what is the model that you're presenting. He doesn't care what a random forest is or what a logistic regression is. He cares much more about the end product which you are packaging and giving him. So that's an important component of the entire exercise, right? And then the creation of appropriate binary variables as well as part of the entire exercise which follows. Now, this might seem a bit up in the air. I can understand that, but it will become a lot clearer when we actually look at the data set, right? So having said that, let's just dive into the data set. And so you guys can get an idea of what the data actually looks like. And so,
Sir, can you explain the concept of the random forest?
I will not explain the concept of random forest to you in this session, because I will primarily go into the application of logistic regression on the data set. So we don't really have that much time to cover two methods. If I had more time, I would have shown both methods to you. So for the purposes of this session, I'll primarily be using the logistic regression as application to the data set.
Okay.
So let me just go through the data set. This is pretty much live data. So actually, when preparing for this session, I was thinking of how many observations to take, which would be sufficient to present a substantive analysis. So initially, the data set actually considered 249,000 observations, but that was actually, I think, a bit too much in terms of model runtime, also in terms of emailing through Gmail. But so I've basically considered 11,000 observations for this, which you will see over here. 1 second. So 11,679, I think it is. So now, let me just go through the data with you. Let me just show you the original data actually first. Let me just show you the original data. So this is pretty much the grassroots data which the client gives us in terms of in terms of what the data looks like coming out directly from the CRM. I'll just do a brief run through of the columns. So these are basically customers who have been called out to by the retention desk to see if they can retain them. As I told you, the objective here is to try and identify which customers are retainable. That is, what is their probability of retention, right? So having said that, we've considered a variety of customers who either been retained or they have not been retained based upon past outcalling by call center agents at Airtel. So if you see over here, the data set consists of 11,682 observations, if you see at the bottom of my screen. So the data set initially was actually 249,000 observations. I have sort of chopped it a bit to make this more manageable for this 1 hour session. And it basically takes me through a variety of columns. The serial number, the date, just ignore the column C. This is basically a random output column. What you need to start considering is these columns. So if you see, this column is the call result. So essentially what this means is that when I've outcalled a particular customer, what has his response been? So, I mean, if I just apply a filter here, if you see, there are a variety of reasons the person has responded to. He's either abandoned the call, he's either answered the call, maybe it was engaged when the call was made, when it was dropped or no answer, and the variety of other. Group callback is another option which Airtel internally considers, which basically says that a particular division of Airtel will call back the customer. Then there are other factors like no answer, others, and various other internal categories. But essentially, the objective of this column is to try and identify what is the response of the customer when the call was made to him to try and retain him. That was the objective. So now, if you see the circle, this is essentially where the customer belongs. The customer can belong in Tamil Nadu, Karnataka, Gujarat, etc. And so this is where the particular customer who has been targeted, where he belongs. So if I just open this filter, if you see, there are a variety of areas which I'm considering. Now this is data primarily for South and West India. So there is only data for Gujarat and Karnataka and Mumbai and Tamil Nadu and Andhra Pradesh. There is no North India or East India data, because Bangalore, of course, as a call center will only cater to the south and the southern and western parts of the country. Then if I go into contacted, this column, this basically says whether the person was contacted or not. That is, essentially forget about being retained or not retained. I have outcalled him. Was I able to reach him or not? So that's essentially what contacted and not contacted means. Then this is the most important column, the retained column, which basically says whether the customer was retained when I called him up. Was I able to convince him on the call ki please stay back, please be an Airtel customer and carry on being one. So if the call center agent was successful in retaining the customer, then we say he's been retained. If not, it's not retained. Now you might notice there's a third category here, flow to field. Flow to field essentially is Airtel's way of saying that I am not able to retain the customer, but I think if I have a in-person meeting by sending an agent to him, maybe I can retain him. So flow to field means flowing the call to the agent who is working in the field, who will go to the customer's particular location and try and convince him to stay back. Region is actually something much more granular than the circle variable which we consider here. So if you recall, circle was on a statewide basis. So region here is more on a city basis. So Ahmedabad, Bangalore, Ernakulam, if you see, all these are southern cities in India. So if the client, for instance, is not interested in a statewide analysis, he wants a citywide analysis, we need this particular variable to consider. Zone is a further deep dive. The client will very often, for big cities like Bangalore, will want particular idea about retention for particular parts of Bangalore. For instance, Bangalore East, North or South, to know where retention is suffering. So we can do a further deep dive based on that. Okay. Now let me just complete a couple of other variables. The source is the source through which the person has actually said, you know what, I'm not continuing with Airtel. Be it email, be it through an employee, be it through other options, etc. Right. Now this is a very, very important column, the CC reason. The CC reason column has basically the type of reasons you would have for actually disconnecting your connection. So if you see affordability issue, bill related issues, competition, which basically means that the person might be shifting to a Reliance or a Vodafone, network experience, low or no usage. Maybe the person is shifting to the US, so he's giving up his connection. So these are the reasons which the person has stated at the time of giving up his connection, and they will be instrumental in deciding as to whether this person is retainable or not. Hello?
Excuse me, sir. Yeah.
Yeah.
So can you hear me?
Just one second. Just one
Yeah.
second. Hold your thought for a
Sure,
second.
sure.
I'll come back to you. Yeah. So let me show off a couple of more of these columns, and I will personally ask the questions. So this is basically the column which relates to the reason for disconnection, right? Now, if you go to CC sub-reason, it is something even more granular. It's again a drill down of CC reason, but now I'm making it even more granular as to why the person disconnected, whether it be the product being expensive, sales wrong commitment, etc. Now, when performing a machine learning analysis, very often having so many levels. So what is a level? A level is basically a sub-level, subdivision of a particular variable. So this is a variable. These are the levels. So already taken a competition, already taken a new Airtel, these are all levels. Okay. So very often in machine learning algorithms, particularly in random forest or a logistic regression, the algorithm collapses if the number of levels exceeds 30. So if you see this particular variable, the number of these variables are going to exceed well beyond 60. You see they go on and on and on and on. So because of that, we will be discarding this particular variable P for the purposes of this analysis. We will resort much more to the reason variable, which consists of a variety of levels. Okay. So I just have a few more variables and I'll ask for your questions. So this is the customer segment variable, which basically says the customers can either be business customers or consumer customers. Airtel obviously caters to a wide variety of people. So are these people business customers or are they individuals? Then if you look at this one, service segment, if you see there are gold, new, platinum and solitaire. Based upon the amounts of their bills and their allowances, etc., they are classed under each of these categories. And finally, we have customer class. That is whether the in-person is a commercial customer, whether he's a medium enterprise, whether he's a reseller, whether he's a stay-at-home person or a small enterprise. And so the classification has been done by that as well in terms of people who have disconnected. So that is pretty much in sum and substance the entire data set in terms of columns which comes out of the Airtel CRM, a subset of which we will consider. So before we embark on the analysis, please let me know what questions you have about the data set.
Hi, sir.
Yeah.
Sir, I was asking that you said in random forest, we or any regression logic, we say in any analytics, you can't have sub level more than 30. So how can we get rid of that? Because the more the sub levels are, the more we can get details of anything like any field or anything. So is there any
Well,
other process?
yeah, there's a couple of things you can do. So if, for instance, here in column P, if you see there will be around 60 odd levels, one solution around it is to do a bucketing exercise. So essentially, if you have to go through all the levels and try and see how many of them are akin to each other, try and club them and form individual buckets within them to reduce the number of levels from 60 plus to somewhat lesser amount, so that random forest can handle it. If that does not work out, what you can do is a couple of other techniques, a couple of other solutions are there. The second solution is to dumbify the data. I'm not going into detail as to what dummification is. It basically means creating a separate column for each level. There is a function in R which allows it. For each level, you create a separate function. But I would not advise it because that very often creates problems at times of prediction. The third solution is you can maybe try a more advanced method like maybe a artificial neural network or something, which can handle more levels in terms of managing the data. So you can try any of these three methods when you have multiple levels. But ideally, the best solution would be to bucket it to try and make it as small as possible. Any other question?
Hello.
Hi, sir.
Yeah.
Hello.
Yeah.
Has actually, sir, I want to know that on the basis of this data, after analysis of this data, we have to take a business decision or decide our marketing strategies that we can means improve the retention or the don't lose the customers. Is that the ultimate goal?
At the end of this analysis, the objective is to try and give business an idea in this particular case as to which customers are more retainable as compared to the others. So we'll do a stack ranking of probabilities for each of these rows in terms of who are retainable and who are not retainable. And so people who are retainable, we will ask the call centers, that is business, to try and focus on them to try and reduce the amount of churn. And so it's basically as part of a prioritization exercise to see how they can formulate their plan in terms of time management as regards focusing on those customers who can be retained rather than who have no hope at all.
Okay.
Okay, no other questions? Okay, fine. Cool. So then
Uh,
let's just go to,
Excuse me, am I audible?
yeah.
Yeah, just a small question. What is the target variable in this data set?
Good question. So that's a very good question. The target variable over here is actually the retained variable over here. Because remember, at the end of the day, I'm trying to see what is the probability of retention. These are all people who I have called out, made out call to, and I've basically tried to convince them, please either stay back or I mean stay back, or if they have succeeded, the customer has stayed back, or if the customer has not. So if the person, we have been successful in retaining the customer, then it will be retained. If not, it's not retained. So essentially, this is our target variable. But having said that, we will not keep the target variable in this form. That will become much more apparent when I show you the R code. I will transform this target variable a bit in terms of who should be retained and who should not be retained. But ideally, the objective is to try and see the probability of retention. So the base target variable will be this one, column K.
Okay, but in case we have put retained as an comment in this column, then we'll be not taking retained for the modeling purpose, right? We'll be taking float to field and not retained as the 1 and 0 for the target variable. Am I correct in the approach?
As I just told you, I will show you how the allocation gets done.
Okay,
so
sure.
Just hold your horses to then. Okay. Any other questions apart from that?
Okay. I am audible.
Can you explain the column?
Am I audible?
What is column Q?
Column Q.
Reasons.
Yeah, so the column Q essentially is whether the person is a business customer or a consumption customer. So it's basically, very often Airtel has business connections. So you might have formed a company, and then Airtel gives you a group plan for all your employees. So are you that sort of a business connection customer, or are you an individual customer? That's pretty much what column Q is.
Hello, am I audible?
Yeah.
Hello. Yeah. What is the average number of levels we usually have in real market world, as logistic and random forest are in stream nowadays?
So your question is, what is the average number of levels are usually there in a variable? That's your question?
Yeah. In telecom industry, like whether customer is being retained or not, what are the average number of levels that companies will usually prefer?
See, it's not about preference. It's basically about ease when it comes to the modeling exercise. So I think anything up to 25 levels can be easily handled by any algorithm. So anything up to 25 is easily manageable. Anything above that, you would have to start undertaking some form of bucketing exercise in order to be able to handle it. So it's not so much about preference. It's more about ease. The lesser the levels, the easier for you to handle it. Okay, so let me just go on now and show you the code. Okay, just hang on a second while the R code loads. Okay. So let me just close this. So the R code essentially begins with, reduce the zoom a bit. So the R code begins with firstly loading the data into the system. So after setting the working directory, that is basically, after you've done that, you basically try to load the data onto the system. So if you see over here on my desktop, the file is called Airtel retention data. So having said that, when I go over here, all I have to do is just read the file called Airtel retention data, which is a CSV file, and I load it into a particular object. So once I just run this simple line of code, you will see the data is now in R, and you can see that at the bottom of the screen over here. So R is actually very, very versatile in that respect in terms of loading CSV data. So after having done that, it's possible for me to view the data, and that's what the data looks like in R. The same thing I showed you in Excel in just a couple of clicks is now in R, and that's what it looks like. The same thing, there's no difference. So now that we have done that, we want to try and explore the data a bit to try and understand as to what the data looks like and what it seems like. And for that, we use a particular package called Summary Tools. So after installing that package in R, we basically apply that on the model. Just one second. And using the df summary function, I basically get an output like this. So what does this output produce? So if you see over here, it basically gives me the amount of spread out of each level. So if you recall, within the customer class variable, there were a variety of levels to it, like commercial, corporate. So these percentages basically tell me the amount of spread of each of these levels individually, right? Similarly, for customers, for service segment and for customer segment. The ideal objective of an exercise like this is pretty much to see if there are any missing values. So if you see over here, there's this number 100%. This number 100% basically means that how much of for that particular variable, how much the data is there. So if it is 100% throughout, which it is, if you see, for every variable I have 100%, it essentially means there are no missing values in the data, right? So if you see, every variable is 100%. So this particular function is actually very, very, again, very versatile, because it not only allows you to the spread of each level within a variable, but it also allows you to see the missing values in the data. Okay, so over here, if you see, that's the case for each and every variable. Now let me show you, since we're talking so much about levels, let me show you a particular variable which has too many levels. Let's see this variable, for instance, zone. So this 31 others means what? This 31 others means apart from Ahmedabad, Naculum, etc., there are 31 other levels, right? So R still somehow manages that. So this variable source had 12 other levels apart from the ones you already see on your screen. But what if it becomes unmanageable? So that's what happens in the CC subregion. You see 65 others. So apart from these numbers 1 to 10, there are 65 others which are already there. And for this purpose, we need to discard this particular variable for the purposes of the analysis, right? So the df summary function is an extremely easy function to use, and it's extremely widespread in the benefits it provides you, right? Then after that, we basically try and clean up the data a bit. So we look at the column names of the particular data object, call names of data 1, and that's basically giving you the column names of all the data variables that you've seen over here, right? All these variables. So once we have done that, we will try and clean up the column names a bit, because it allows for easier calling of variable names. So if you see, there's a lot of other stuff which is there in the column names. There's an underscore, there are full stops here, and so is there a way we can clean up the column names? And as it turns out, there is. We're using something called the stringart package, and once we do that, we use some code within R to clean up the column names. So over here I'm removing all underscores, over here I'm removing all full stops, right? There is a way to do it more easily in one line of code, but I'm nonetheless splitting it up a bit for you guys to try and get you guys to understand what is going on. Essentially, I'm trying to remove underscores from the column names. I'm trying to remove full stops from the column names, right? So if you see, there's a lot of full stops and a lot of underscores in the column name. But once I run these two lines of code, and then if I look at the column names once more, if you see, the column names are clean now. There are no full stops, there are no underscores, right? So that's pretty much a data cleaning measure, which is used. It makes it much more easy for you to call variable names later on in the exercise. So now, to answer the question which someone was asking me earlier as to how to what would be the target variable. So as I told you, the target variable will be my variable over here, which is my retained not retained, which has three categories: retained, not retained, and flow to field. But ideally, for a logistic regression exercise, my dependent variable needs to be binary, which is basically of a 1-0 nature. So for that to happen, I need to allocate 1 to something and I need to allocate 0 to something else, right? So to do that, I use this line of code. So if you understand, that's why I asked you to hold your horses earlier, because I would address it. If you see over here, I would say if else data $1 retained, not retained. Dollar basically refers to a variable. So data 1 is the data set, which if you recall, that's what we were referring to, data 1 being the data set. And using retain, not retain, I am saying if it is retained, give me a 1. If it is not retained, give me a 0. So if I run this line of code, right, and then if I view my data set once more, if I scroll to the right, if you see a new variable has been created. So this variable, the code variable, will pretty much become my target variable going forward. So that pretty much completes the data set in the sense that I now have a full set of independent and dependent variables, which I will consider for the purposes of my analysis. The code variable being my dependent and all the other variables becoming my independent.
Sir, one small doubt, sir.
Yeah.
Sir, here they have given whether they have retained or not retained. In case if they didn't give and they are asking based on the history of the data, they want to categorize or prioritize who are the most valuable customers. Then how can we use this algorithm?
It depends on it depends on the variable list which you are given. So there's no hypotheticals here. So whatever variable list you will be given, according to that, you will have to decide as to what sort of an algorithm you'll have to use.
Okay. Then also we need to categorize which is the dependent variable. Currently they have given here a returned or not returned, so we are taking this one. In case if this was not there and they are asking to categorize, which variable we need to choose out of all the variables?
Then you would not be able to categorize, right? I mean, how will you prioritize otherwise? There has to the objective of this exercise to try and identify who can be retained and who can't be retained. So that is why
based on the money every month transactions or every month recharges they are doing and from the
1 second. No, just hold on a second. So I don't want to speculate about that. Both the data there can be I mean a million types of possible data sets which we can get just for this particular problem. So what can happen or could happen is not something I want to speculate about. But there has to be a clear-cut response variable in place on the basis of which you have to prioritize. Now that could be something like what is there now, retained, not retained. It could be expenses, it could be spending, billing, like you said, or something else. But that I don't think it's it's possible for us to speculate as to what that might be, right?
Okay, sir. Because I am new to this domain, like this domain knowledge, so I have asked the real-time problems, how they will get the problem statement.
That's what I'm saying. So what you're saying is not wrong, but having said that, I mean, you can't speculate as to what a data set will be. So in a particular data set, if it's not possible to identify what is a response variable, then maybe you will not do a classification analysis. You can maybe do a clustering exercise, or maybe some other unsupervised learning exercise. But as I said, because there are so many points of speculation here, I wouldn't want to try and make a guess as to what we would use then.
A question I have.
Clients or customers will provide all these kind of each and every minute data also, right, for us to categorize all these things.
What was your question, Shirali?
Yeah, so my question was, if we had 3 levels, we could have gone for a multi-class logistic regression than a binary one.
Absolutely, we could have.
So why are we trying to go for a binary logistic here?
Because I mean, there are 103 people attending this call, so I'm not sure if all the 102 others who are attending it, apart from yourself, 101 others, whether they'll be aware of what a multinomial logistic is. So a logistic regression is a much more easier method to start off with if you're not aware of machine learning technique. Okay.
Hello.
Any other questions?
Hello.
So just this one line explain, preparing data for modeling, that line.
Yeah. So what this particular line of code, this one?
Yes.
So this is basically an if-else condition. So what I'm saying is the data set $retain not retain, which is basically your variable here. Your variable your variable over here, which is basically has 3 categories: retained, not retained, and flow to field. So now I want to say that I only want to focus on the people who are retained and find out the probability of retention, right? So having said that, I'm applying an if-else condition almost exactly like you do in Excel, and saying that data $1 retain not retain, which is your variable, is equal to retained, then you give me a 1, otherwise you give me a 0. And with this concept in mind, you please create a new variable called code. Okay. So that's exactly.
I have a question here.
Yeah.
So how we are concluding retained as 1? Why not 0?
Because the whole idea of a logistic regression is that the positive class must always be 1. So if I'm trying to find out the probability of retention, I'm not trying to find out the probability of not retention, right? I'm trying to find out the probability of retention. So having said that, the positive class here should be 1, which is retained.
Okay.
Okay, so let me go on. So now that I've created the new column and I've created the new data set, I need to remove certain variables, right? what are these variables I need to remove? So I basically need to remove the serial number because that should not be part of any regression. I need to remove the date. I need to remove the last call because it's a rubbish output variable from the CRM, and the contact info. So these are basically variables which don't add any value to my exercise. So I will take out variables 1 to 4, which is exactly what I've done here. Similarly, I will remove variable 11. Now, obviously, I've already created a code variable based upon this retain not retain variable. And so I will remove this variable because I already have a code variable in place. So having said that, I will remove variable 11. So, and similarly, I will remove the sub-reason variable, which we have already discussed. It consists of around 70 levels. And now it's not possible for us to subdivide it at every stage and bucket. And because of that, we are using CC reason, and that's why we'll take out variable number 16. Having done that, we created a new data set called data2. And when I view data2, I get a new data set with a few of the columns locked off, right? Nothing other than just basically taking out some columns which I don't want. The next step is to try and basically subdivide the data into train and test sets. And so I use something called the carrot package, which I use to subdivide the data into train and test. And using the create data partition function, I divide the data set 70-30, right? And so I divide in two sets, final train and final test. And why do I do that? As I told you earlier in my PPT, the objective basically is to try and see how the model is learning on the basis of the data and to test it out on unseen data. And that's why the division into two parts, train and test, right? So, and then we go into the model formation. Now, to do a logistic regression, you can use a variety of packages. There is one package called the GLM package, which is generally used for a logistic regression, but I tend to prefer this package called NNet, which is, I think, a lot more multifarious in its capabilities. It is also used for neural networks. And so once I call that package, I run a logistic regression called churn model. I use the multinorm function, but set the family as binomial using the data set final train, right? Because that's my train set as I've defined over here, on the basis of which the model will be trained. So I create the logistic regression model, and as you see, the iterations are still running while the logistic regression is running. And once it converges to a feasible outcome, I can say I actually have a logistic regression model in place which is feasible. Right now, once I do that, I start now interpreting the model, start understanding it a bit more. So, one second, taking some time to run. So the next step is basically to try and plot something called the ROC curve. Now, I will not go into all the details of logistic regression and ROC curves in this session. Yeah, as it is pressed for time.
Yeah, can you later see the list of variables that came into the churn model?
Excuse me?
Can you just scroll up and let us see what is the variables that are coming?
So these are the variables which are coming. I already showed that to you, right?
No, the variables that came in the model.
So these are the standard
produced after the summary.
So these are all the dummified variables for each of the levels which have come.
Okay.
For all the zones. Okay. So now the next objective is pretty much to try and understand the data. So we use something called the ROCR package for that. And here is where the critical part of the model comes. So what I'm doing now is I'm applying the churn model on the trained data set and getting probabilities of churn for each of those individual customers. Probabilities retention, sorry, of each of those individual customers. So once I run this line of code and I say call out predict 1, if you see, I've got probabilities of retention for each of the customers in the train set. Now, these might look to you to be very large numbers, but keep in mind that there's an exponential here. So these are the probabilities of retention for each of the customers in the train set, which I considered, right? But suppose now I want to do the classification. I want to do the classification for those who are aware of logistic regression. I do a classification by setting a particular cutoff, which in this case is 0.5, and I divide the data set 1-0 based upon that. And once I do that,
a small question I have. How are you getting that the optimal cutoff for this exercise would be 0.5, not something else?
That is the standard cutoff which we always begin with before adjusting the cutoff later based on the confusion matrix.
Okay.
So now that we have
sorry to interrupt. Can you please once again go through the churn model line of code?
The churn model is basically just your using the multi-norm regression, code was the dependent variable which I told you, and it's regressed on all other variables using the dataset final train. And the family binomial is basically I considered a binary dependent variable, which is 1-0 in nature.
Okay. Thank you. Thank you.
Yeah. So now that I have actually done the classification 1-0, I've actually basically said, in my opinion, as per the model, who should be a retained customer and who should not be. That's what basically this output tells me. So now, if I'm looking at the ROC curve, based upon the model which I've created, based upon the predictive outcome and the actual outcome, the ROC curve will basically tell us how good our model is. Right. So there's a way to see how the ROC curve is doing, and I will show you that. Just one sec. I have to install this. Just one sec. Yeah. So I had actually not installed the package, so now it will run. Let me just show you what the ROC curve looks like. Yeah. So the ROC curve here is basically the comparison between the true classifications and the false classifications in a nutshell. So essentially, if you see it says false classification on the horizontal axis, true classification on the vertical axis, the closer the curve is to my top left-hand corner, essentially the better the model is, because the lower the false classification is, the higher the true classification is, right? So very often the ROC curve is used in terms of how good the model is, and the higher the curve, the better it is, and more the area in this section, the area under the curve. Now, it's possible actually to get a value for the area under the curve, and that is given by the AUC, which actually stands for area under the curve. When I do that, this line of code over here, if you see, I get a number which is equal to 0.70. So this 0.70 essentially is the area under this curve, which I've got here. So as I told you earlier, the higher the curve is, the lower the false classification, the higher the true classification, the greater the area which is there under the curve. So a 0.71 area, pretty much, it means that it's a good model which you can consider. So the ROC curve and the AUC, the area under the curve, are very good depictors of how good your model is. Now, let's just move on and just consider a bit more as to what the end objective was, which is pretty much determine probabilities of retention. And for that, we consider the table function, which gives us a comparison between the predictions and the actual value. Right? And so for that, I consider the table function, and that basically gives me an output over here, if you see, a comparison between people who were actually retained as compared to people who were predicted to be retained. Now, this will become a lot clearer once I show you the confusion matrix. So let me just generate that for you guys. So the confusion matrix, okay, the confusion matrix looks like something like this. So this basically says that my model has an accuracy of 76%, which is pretty good. So someone was asking me as to why 0.5 is used first. So if the reason is basically, if I start off with a 0.5 cutoff and I get a 76% accuracy, there is no reason for me to tinker with the cutoff anymore, because I've already got a very good accuracy. So 76% accuracy is definitely something to write home about. So I don't need to worry about the cutoff anyway. Now, what do these numbers mean? One second, please let me finish.
Okay, sure.
Now, from the confusion matrix, essentially, what does the confusion matrix mean? So I don't know what your name is, but there are a lot of people on this call who might not have a background in statistics, right? So if you have any individual questions, I'll be happy to address them, and maybe you can do so via an email or something, because I think it will pretty much leave everyone else in a limbo if you continue asking these questions and they are pretty much at sea as to what you're asking about. So what does this confusion matrix show? If you see, what R actually does not tell you is that in the columns we have the actual numbers. In the rows we have the predicted numbers. Now I won't go into too much detail about the theory of a confusion matrix, but the idea basically here is that for this number, for instance, 1477, it essentially means that out of all the people who were predicted to be retained, because remember 1 is retained, out of all the people who were predicted to be retained, 1477 were actually retained. So that is pretty much what the sensitivity is, which is over here, 0.5517. So essentially over here, this 4739 are 0 here as well as 0 here. So essentially 4739 means that out of all the people who were actually not retained, we predicted 4739 of them correctly, right? So these are 4739 and the 1477 are essentially the correct classification, because They were actually 0 and we predicted them to be 0. They were actually 1, we predicted them to be 1, right? And so because of that, these numbers actually turn out to be our true positive and true negative numbers. Now, I won't go into too much of jargon. As I said, it's not really a session about on logistic regression. It's more about the applicability of analytics. But that's pretty much the numbers which we look at the end of the day in terms of how successful our models are. So this output which you see in terms of the confusion matrix is actually just another replication of this output from the table function here. Just that now your life has been made a lot easier by the confusion matrix function, because now you've been given the accuracy as well as the sensitivity. So the idea should be to have as high sensitivity as possible and accuracy. Now, coming back, just sort of putting the theory aside for a time being, the sensitivity essentially tells you, for the purpose of this analysis, it tells you out of all those people who were actually retained, how many did the model predict correctly. So it basically says, I've outcalled 100 customers. I've managed to retain, let's say, 90 of them. Out of the 90 that I've actually retained, maybe 60 the model predicted correctly. So if it is 60 out of 90, then the sensitivity should be 6 by 9, which is 67%. So that is another very important metric which we look at, right? So that is one very good metric when it comes to classification. But apart from that, there are a variety of other metrics which we look at. Another one is which is called the McFadden R-square. So the McFadden R-square is actually also called the pseudo R-square. It is after Daniel McFadden, who won the Nobel Prize for econometrics in 2002. And so essentially, it is like the R-square in a linear regression. Very similar, but just that because the standard R-square is not applicable in a classification setting, we use the McFadden R-square here to try and depict how good the model is. Now, while the package is loading, I'll just tell you, in general, a McFadden R-square of more than 0.25 approximately is considered to be pretty decent. So when I actually do that, if you see, I get a McFadden number here, 0.27. So our model is pretty decent in terms of its explanatory power. So as I said, I'm not going so much into the theory. I'm just giving you some interpretive keys of how to decide what a good model is. But the idea should be pretty much as to how does it how does it actually help business? And that's what I'll show you now as a final step. So if you recall, we had partitioned the dataset earlier and into train and test. And now that the model has learned something from the train test set, why don't we just apply it to a test set to see how the model is doing on unseen data? And that is exactly what we will do here, right? But now I want to sort of make my output a bit nicer and cleaner, to make it seem that, what is the probability of retention of customers which the model has not seen. So I actually convert it into an Excel file, right? And I create that Excel file on my desktop. So this line of code, write.csv here, allows me to create a file on my desktop which basically says what is the probability of retention. So once I run this line of code, there should be a file called churn.csv on my desktop. Let's see if that is the case. There is. So once I open this churn.csv file, if you see in this churn.csv file, there are 3,500 observations. Remember, in my original data set, there was 11,000, which I split 70-30. So essentially, this is the 30% of the data set. But now, unlike before, with my original data set, I now have a additional column appended on the right hand side. So let me just convert this to percentages. So now if you see, I have percentage numbers for each customer. So for each customer profile, in terms of the circle, the contacted, non-contacted status, the region, the zone, the CC reason, I now have a probability of retention. So it is now possible for me to stack rank these probabilities and then basically say who has a higher chance of retention. So let's consider this guy over here. He has a retention probability of 76%. That means I would definitely want to call this guy first and try to retain him, because there's a good chance I might retain him. So this guy has a retention probability of 87%. So I would definitely want to outcall this guy first and try and see whether he can be retained or not. So I would definitely want to call this guy first as compared to, let's say, this guy, who has a 13% chance of retention. So someone asked me a bit earlier, what is the value add of our exercise? The value add is precisely this, that previously the call center agents were sort of flying blind in terms of who to call first. But what we give them is a prioritization exercise in terms of the probabilities of retention of individual rows. And if particular rows have a high probability of retention, whatever probability threshold we want to set, then we will definitely call them first. That is the whole objective of any prioritization exercise through machine learning. So now, having shown you the last column, I'm pretty much done with whatever I wanted to cover as part of this whole analytics applicability to machine learning. I think they're already over by 15 minutes. But in case if you have any questions for 5 minutes or so, I'll be happy to answer them.
Am I audible?
Yeah.
I usually attend many webinars like this, and I usually see that trainers always do coding in R Studio. But when Google, I usually see that Python is on trend. So what do you think, Python or R, which one would be better? Or you can say Octave or MATLAB?
That is actually a very good question. To be very honest, I have predominantly worked in R. I know Python, but I know R a bit better. I think it's totally a matter of taste. I think if you've learned Python first, it is. I mean, it should not be very difficult for you to learn. But Python is very different from R. R is, I think, a lot easier and much more, straightforward when it comes to code in terms of applicability of packages. Python is not so straightforward. Python requires a variety of packages for almost everything you do. So because of that, I personally prefer R. That's probably because I've learned R first. But if you've if you're learning Python, it's extremely popular. It's widely flexible and widely used across a variety of sectors. It's purely a matter of taste. I mean, I prefer R because of its.
I know Python is flexible, but what is the future of R?
that is a question I can't answer, but I can say that Python is taking over a larger part of the industry. So R is definitely taking a backseat, to be very honest.
Okay, one last question. Yeah. How could you differentiate big data, Hadoop, and machine learning?
What and machine learning?
Hadoop.
Hadoop relates to big data. So Hadoop relates to management of terabytes of data which can't be managed in a particular R session. So machine learning is basically leverages on something like Hadoop to perform particular analyses. So Hadoop is something at a different level altogether, which I think many people have not reached. So PySpark is, for instance, something which is used along with Hadoop. So it's not really a comparison.
Yeah.
So
Two questions from
please
me.
drop your email in the chat box so that whether I question. Could you drop your email in the chat box?
Hello, sir.
Yeah.
Sir, I have one doubt. Like based on this logistic regression or whatever data set we got, the problem statement is if there are 10,000 problems listed down in one Excel sheet, and our target is to predict which problem will come again based on some problem description or some based on this thing. In that scenario, what would be our dependent variable? Because there will be a combination of 4 variables the problem will define.
So you can choose your dependent variable based upon what you think your suitable problem is. So it's a combination of 4 variables. You'll have to apply some sort of a combination statement, maybe an if and or something, to combine it into a single dependent variable. It's actually a common practice to combine multiple variables into a single dependent variable through a if and statement. So it depends upon.
Any suggestion from your end? Any suggestion algorithm we need to use for those kind of scenarios?
So as I said, if you don't have a dependent variable in place, the ideal thing to do would be not to use any supervised learning method. So you can either use maybe a clustering exercise. You can use a neural network. Primarily, clustering exercises go a long way in such a situation.
Okay. After clustering, again we need to forecast or we need to predict. Two things we need to do, right?
So no. So clustering is not a predictive exercise.
Yeah, it will group the similar or nearest objects.
No, I think you're getting a bit mixed up between clustering and a predictive exercise. Methods like clustering and Ques&Ans are not. Ques&Ans is a predictive method, but clustering is not a predictive method. It will basically just give you a profile of individual cluster members, but it's not predictive in nature in any way.
Because in my current workplace, I'm hearing this kind of problem, so I want to give a try to practice with R So I tried to ask a suggestion from your end, like what kind of
Yeah, so
algorithm we can.
you can use clustering. So you can use hierarchical clustering or k-means clustering based upon what you see fit. R is considerably flexible in that regard, but as I said, it is not a predictive algorithm. It is a profiling algorithm.
Hello.
Okay. Thanks, guys. Thank you for the session today. If you have any other questions, feel free to email me. What I'll do is I'll just put my email ID in the window.
Hello.
Yeah, so you can, I think, email me with your questions. I'm putting my email ID in the window. So feel free to email me whatever additional questions you have, because I think we're already way over, around, I think, 20
Can you
minutes
take
over.
one last question?
Regarding, please go ahead.
Yeah, so how is region or zone be affecting the retention of a customer of a customer in this case? So is there is some significance of this region or zone on this retention, or the priority to given a retention?
So do you think the retention of a customer, let's say staying in Jhumratalaiya, who's living in some village and probably milking cows, do you think his probability will be more or less than somebody who's living in Worli, Mumbai?
I don't know about that. That is why I'm asking you the question, right?
Why don't you email me? Please email me your question.
Right,
Because
Aditya,
Okay,
thanks a
sure.
lot. Shiladitya will not take any more questions. Thank you, Shiladitya. And Aditya, thanks a lot for cooperating and extending the session. And
yeah.
guys, thanks a lot for attending. We'll send across the video of this session with a highlight of whatever Aditya discussed. Aditya has been grateful to share his email ID. So should you guys have any questions, feel free to email it to him. When you do that, make the questions very, very specific. And so that he can give you specific answers. Thanks a lot, everybody. I know it's been a little late and there was a little bit of technical glitches right at the beginning, but thanks a lot for attending. Thank you, Aditya. Thank you, everyone.
Thank you. Thank you. Yeah. Bye-bye.
Yeah, thanks, Aditya. Thanks, Aditya.